The reciprocal function is y equals 1 over x. That would be the parent function. And what it looks like is generally it's curved and it hugs the x and y axes, and it's also in quadrant 1 and quadrant 3. That's what the normal parent function reciprocal function is. Then, if you happen to make it negative, what will happen is that actually flips it over the x-axis. It's a vertical flip, and that would put it down here and up here. Each branch of this thing, each part that's separate is called a branch. So each branch is flipping over the x-axis in a vertical motion. So that's called a vertical flip or a reflection over the x-axis. So this negative, whenever you see a negative on a reciprocal function, it puts it in quadrant 2 and quadrant 4. That's where the curves go. The x and the y-axis act as asymptotes, and so that means they will be getting closer and closer to the x-axis and the y-axis, but never touch. And of course, if we do some transformations that move it right or left or up and down, those asymptotes will move with it. So if I moved it 3 to the right, that cross of asymptotes will actually move over as well to the right. Or if I move it up or down, the whole cross will move up or down with it. So those asymptotes move when the curve is transformed as well. So here's a more general form of the reciprocal function with all its transformations involved. Now there are other transformations that could happen, but these are the most common ones, and these are the only ones we're going to deal with in this lesson. So the a is almost as if it has been multiplied by the 1 over x. If you multiplied a in the front of 1 over x, that a could end up on the top over x. And so it's like when you had something in front of a function multiplied. That caused a stretch or a shrink in a vertical direction. It affects the y values, not the x values. And so this is a vertical stretch or shrink, or compression. And so if it's something like 3 or 1.5, anything bigger than 1, or if it is something that's less than 1 but greater than 0, those would be compressions. Things that are bigger than 1 would be stretches. If a is negative, so if a is negative, then that will cause it to flip. It's a vertical flip, which means it's going to flip over the x-axis. So when you're looking at the a number here, I'm talking about the a without the sign, or the absolute value of a without the sign in consideration. You do the stretch or the compress depending on what the a is without the sign. Then if a happens to be negative, you also do a vertical flip over the x-axis. Then the other transformations are familiar as well if you've done transformations with other functions. The h right there is considered a change inside the function, where k is considered to be outside the function. And if you remember, this is a left-right shift, and it goes reverse of the way you naturally think it should go. And so in other words, if it's positive, you go left. If it's negative, you go right. And that's kind of the reverse of what you would naturally think. So that's how I like to think of that one. Then the k over here, or whatever's being added or subtracted on the end outside the function, that is going to be an up-down shift, and it's not reverse. So if it's plus, it goes up. If it's minus, it goes down. And so those are the same shifts that we've had in other transformations and other functions as well. So when asked to sketch a graph that looks like this, these are some transformations that have been done to a reciprocal function. And in blue, I went ahead and graphed the parent function for you. Now this is very rough, but let me tell you some general ideas of what happens here. When you do plus 5, that moves the entire thing left 5. And the easiest way to show that is just to move your asymptotes to where it is left 5. So move your vertical asymptote there. And then let's look at the minus 3. What it will do, it will move the whole thing down 3, which would put your asymptote at negative 3 instead of at 0 where it was before. So that's what those two shifts do. And then what the 2 does is it stretches it vertically, but one of the best ways to, or one of the more noticeable things, because it's still going to make generally the same shape, but one of the things you might notice is that as the number gets larger, it will kind of move away from the origin or the center of our 0, 0, where our new center is. It'll move a little bit further away, so instead of being where the blue is, it might do something more like this, to where it just kind of moves out a little bit. That's how you're going to notice it the most when it's a stretch. So in other words, when we get over here and say we're just sketching it, we're going to move it a little further away from where our new origin is, if you will, and then move it a little further away from the new origin, something like that. But then the negative puts it flipping over the x-axis, which actually, let's change colors here. So it's going to really have it over here and over here, a little further removed from the center than it was originally in the blue, but flipped and in the new quadrants for negative, and it'll be the whole asymptotes will be moved as well. So I would move the asymptotes and then draw the curve where you think it should go. Now you can always get an XY table off your calculator or make your own and just see where the points are supposed to arrive at. So let's do that real quick. I'm going to put in these values for x since I want to kind of be in this general area. I don't want to be away from the asymptote, so I'm going to choose negative 7, negative 6, negative 5, negative 4, negative 3. Just for an example, we'll plug all those in for x up here and see what y's we get. Okay, what I did was I plugged in and got all my y values, and notice I have one that says undefined. That is because when I plugged in negative 5 for x, I got 0 on the bottom, and no matter what happens after that, right here, this number is undefined. You can't divide by 0. That's an impossible situation, so you can just stop right there when you get 0 on the bottom and say undefined. So let's plot the other points. So negative 7, negative 2 would be somewhere around here, and then negative 6, negative 1 would be somewhere around here, so I'm a little bit off. And then negative 5, the reason it's undefined, shows up on the graph as an asymptote. And then negative 4, negative 5 would jump down to here. And then negative 3, negative 4 would jump down to about here. So my sketch was a little bit off, but you get the idea that it should have looked like that. And so you can make enough points or get enough points off your graphing calculator table to figure out exactly where this thing should be going. But it's easier to draw the asymptotes using your transformations. Moving your asymptotes will help you move the graph into the right position.